Okay, geometry students, in this video we will be learning two more ways to prove that triangles are congruent. These two new ways are called ASA postulate and AAS theorem, and of course they stand for angle, side, angle, and angle, angle, side. Okay, your heading for today will be angle, side, angle postulate, ASA postulate, and angle, angle, side theorem. Okay. The lesson number for today is lesson 4.4. Lesson 4.4, and be sure to include today's date. Okay? Be sure and include today's date. Alright, let's move on. Now, let's start off by looking at postulate number 19. Okay? Please copy this in your notes. I will pause a couple minutes while you copy this in your notes. Postulate 19 is the angle, angle, and actually I typed this incorrect. Hold on one second here, guys. Let me see something here real quick. Okay, sorry about that. This is the angle, side, angle, congruence postulate. Okay, so please make that correction and please copy this in your notes. Postulate 19, angle, side, angle, ASA congruence postulate, and it reads as follows. If two angles and the, here's the key word, included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. Okay, now I'm going to explain this and give you some pictures down here in just a second, but for right now, let me pause while you go ahead and copy this in your notes. The angle, side, angle, congruence postulate. Now students, if you're not done copying this, continue to copy it down. That's fine, but while you're doing that, I'm going to go ahead and draw two triangles here. I would like you to draw these in your notes also, please. And let's go ahead and label these A, B, C, and D, E, and F. Okay, so go ahead and do that, please. And then we want to have an angle and a side and an angle congruent to an angle, side, angle over here. So let's mark this angle here congruent to this angle here. Let's mark this side here congruent to this side here, and this angle here congruent to this angle here. Now students, pause and listen to me. Do you see how this is angle, side, angle? Do you see how this side is an included side between two angles? Here's an angle, and between those two angles is a side. We call that an included side. Okay, and notice we have the same thing over here. We have an angle and an angle, two angles, and then a side in between those two angles. We call that an included side, okay? And that's what angle, side, angle is. It must go angle, then side, then angle. Okay, so write this down, please. If we have two triangles, ABC and DEF, and angle A is congruent to angle D, and angle B is congruent to angle E, and AB is congruent to DE, then I can state that triangle ABC is congruent to triangle. Let's be careful here. A is my first angle here. A has one mark. Which angle over here has one mark? D. Next is B. B has two marks, so which angle has two marks over here? E. And then F would go last. Okay, so when you have an angle, then a side, then an angle congruent to an angle, then a side, then an angle of another triangle, we can state those two triangles are congruent. Okay, I'll pause a second while you go ahead and get caught up in your notes here, then we're going to move on. Okay, now let's go ahead and continue on. Here we go. Now, let's take a look at Theorem 4.7, okay? Theorem 4.7. Theorem 4.7 reads, angle, angle, side congruence theorem, AAS. And it reads, if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. Okay? So I'll give you a second to copy this down. Then I'm going to show you what this means. If two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. And this is Theorem 4.7, the angle, angle, side congruence theorem. Okay, let's go ahead and copy two triangles here, students. And let's go ahead and label these again like the last time. We'll call it A, B, C, D, E, F. Okay, now look what we have. We have an angle, then an angle, then a side. So we're going to call it angle to an angle, then an angle to an angle, and then a side. So we have angle, angle, side, congruent to angle, angle, side. Okay, very important that we see this. So here we go. If, and I'm not going to put what I put the last time about if I have two triangles. We know that already. So I'm just going to put if angle A is congruent to angle D and angle B is congruent to angle E and BC is congruent to EF, then I can state triangle ABC is congruent to triangle DEF. Okay? If A is congruent to D and B is congruent to E and BC is congruent to EF, then I can state these two triangles are congruent. Now I want to show you something in a second here, students, where it's a really common mistake, and if you're not careful, you're going to make this mistake, okay? Now here we go. Please watch it. Sorry guys, excuse me. Please watch this carefully, okay? Look at this. Here's a very common mistake that students make. Watch this, please. Well, it's not going to work, but here's what I want to show you guys. It's real important that you see. Look, sometimes this will happen. Sometimes students will see, okay, we have angle, look, we have angle, angle, side, congruent to angle, angle, side. Thus, these two triangles are congruent. And that's wrong. Please look carefully. That's wrong. Look at this key word in the theorem. Please don't miss this. The key word is corresponding and not corresponding non-included side. Look, you have angle, angle, side. Now what side is congruent? It's the side that has two slashes at the end of the side. Over here we have angle, angle, side, but it's not the corresponding side. This side here has an ending angle of 1 mark. Do you see what I'm saying? In order for us to use angle, angle, side, then we would have to have this side here be congruent, not this side here. Or vice versa, we would have to have this side right here be congruent, not this side here. Look guys, whenever you're using angle, angle, side, you have to have the corresponding side be congruent with the corresponding side. You can't go 1 mark angle, 2 mark angle, side, and then over here go 2 mark angle, 1 mark angle, side. It has to go in the same order, okay? It has to be angle, angle, side like this, angle, angle, side like this, okay? So please understand that. Now, very quickly, and I do mean very quickly, I'm going to do a proof of this theorem, okay? So take some really quick notes. I'm going to go really fast. Are you responsible for this on a test or a quiz? Definitely, yes. You're always, anytime I prove a theorem in class, there's a possibility it could be on a quiz or a test. But I will always tell you before I do that, okay? But here we go. If two angles and a non-included side of one triangle are congruent to two angles in the corresponding non-included side, then the two triangles are congruent. So let's go ahead and quickly draw two triangles. Here's one triangle. Here's the other triangle. Let's call these triangles ABC and DEF, okay? And very quickly, let's state that we have this angle congruent to this angle congruent to this angle, and this side congruent to this side, okay? So that's my given. So my given is angle A is congruent to angle D. Angle B is congruent to, copy all this down please students, angle E, and side BC is congruent to side or segment EF. That's all in your if part. Now your then part is the two triangles are congruent. So we're trying to prove that triangle ABC is congruent to triangle DEF. Well guys, it's going to be really simple what we're going to do. If somehow I could state that this angle here is congruent to this angle here, then I could use angle, side, angle, which we already learned earlier, okay? So all that I have to do is prove that angle C is congruent to angle F, and once I do that, I have angle, side, angle, congruent to angle, side, angle. That's postulate 19, and I could use that for my my reason the triangles are congruent, okay? So watch this carefully. I know that I know that all three angles here equal 180 and all three angles here equal 180. So if I add these three angles up and add these three angles up and set them equal to 180 and then do some substitution, I should be able to prove this really, really easy. Okay, I'm going to go really fast here and this should be pretty simple, okay? So here we go. Number one is my given, okay? Number two, I'm going to state that angle A plus angle B plus angle C equals 180, and angle D plus angle E plus angle F equals 180. And we learned that just the other day. So we can say sum of interior angles is 180, right? Now let's make some substitution real quick here, okay? So for angle A, I can put D right here. So for angle A, I can put D. And then for angle B, I can put E. And then bring down my angle C equals 180. And that's substitution. Okay? So here we go. For angle A, I put D. For angle B, I put E. I brought down my angle C. And now look what I can do here, guys. It's really, really simple what I can do here. And I'm going to do this very quickly. I'm just going to do this. Okay, students, now I'm going to go ahead and probably cheat a little bit on this proof just to save time and to make it a little easier for you guys. I'm going to go ahead and state that angle F is congruent to angle C, and my reason is going to be they're supplementary to the same angles. Now that's not entirely true. I mean, they are. Angle F plus D plus E equals 180. So angle F is supplementary to D and E. And angle C is supplementary to D and E. So really it's okay to do that, okay? So angle F is congruent to angle C. So look what I've stated, guys. In my given, I've stated A is congruent to D, B is congruent to E, and BC is congruent to EF. I've already stated that, okay? Now I'm stating that F is congruent to C. So look what I have. I have angle, side, angle, congruent to angle, side, angle. So I can definitely state that triangle ABC is congruent to triangle DEF, and the reason would be angle, side, angle, which is the postulate we just learned a little bit ago. Okay, postulate 19. So there we go. You need to be familiar with this. If I ask you to prove theorem 4.7 on a test or a quiz, then you need to be able to do that, okay? But I will let you know if I want you to do that. Now, very quickly, let's quickly make a list of the 4 ways that we've learned how to prove that triangles are congruent. Side, side, side works. Side, angle, works. Angle, side, angle works. Angle, angle, side works, okay? Now, let me quickly show you why angle, angle, angle does not work and why side, side, angle does not work. Are you ready? Please watch carefully, okay? You can take some notes on this or just watch. It's up to you. Okay, here's a 60, 60, 60 triangle, okay? Now, what is to stop me from drawing a 60, 60, 60 triangle like this? That's not a very good one, is it? The answer is nothing, okay? I can draw a real little triangle that has 60, 60, 60 angles, and I can draw a really big triangle that has 60, 60, 60 triangles. So just because the 3 angles in one triangle are congruent to 3 angles in another triangle does not mean those 2 triangles are congruent, okay? They might be, but they might not be either, okay? And all I have to do is show you one counterexample to show you these 2 methods can be used. Here's a counterexample right here. Here's a triangle that has 60, 60, 60. Here's a triangle that has 60, 60, 60, but yet they're not congruent triangles, okay? Now, let me show you. Okay, I'm back. Wow, that was embarrassing. It sounded like I was drowning, didn't it? Okay, well, I'm still alive. Here we go. Okay, let me show you why side, side, angle does not work, okay? Watch this carefully, please. Okay, students, now watch carefully. You can take notes if you want to, but you don't have to. It's up to you, okay? Let's say I have a triangle drawn like this, and it's not what I meant to do. Let's say I have a triangle drawn like this. There we go. Now notice I have 30 degrees here, okay? Then a side here that's 6, and then a side here that's 4. Now what I have is side, side, angle. Do you see that? Side, side, angle. Now what if I showed you another triangle that had side, side, angle, 4, 6, 30, but was not the same triangle, like this? Watch carefully. Now look, here's my 30, here's my 6, and here's my 4. Now it's not drawn perfectly, but you get the point. What I can do is I can take this side 4 right here, and I can swing it like it's on a pivot right here, and I can swing it around so that it hits right here, and then draw this line, and it still has a length of 4. And that's what I did over here. So what I have, look carefully, I have a triangle here that has 4, 6, 30, and a triangle over here that has 4, 6, 30, yet those 2 triangles are what? Not congruent, okay? So you cannot use angle, angle, angle to prove that 2 triangles are congruent, and you cannot use side, side, angle to prove that 2 triangles are congruent, okay? And that's it on the video. If you have any questions, feel free to call or email.